Octal is a lot more convenient to work with than binary. However, it turns out that octal does have some disadvantages. If we were to use 2 octal digits, for example, in coding, that would give us only 64 possibilities. And this might be enough for some purposes, but normally we're going to require enough codes to code the keyboard, which has 52 letters, because there's both lowercase and capital letters, 26 of each, and 10 numerals, and then plus we have some other characters. On the other hand, if we were to use 3 octal digits, that would give us 512 possibilities, which is way more than we need. So let's consider the hexadecimal system. Hexadecimal, or hex for short, is a number system based on the number 16. And so we're going to need 16 numerals. Well, we only have 10 ordinary numerals, and so therefore in hex we're going to need some additional numerals. In fact, 6 additional numerals. And what is commonly done is just to use the first 6 letters of the alphabet, A, B, C, D, E, F, to represent the numbers 10, 11, 12, 13, 14, and 15. And just as in these other bases, each hex digit will represent a separate power of the base, in this case 16. So for example, we have the number 3AC. So the C, remember, it's going to represent the number 12, so 12 units. And then A, you remember, that represents the number 10. So we have 10 16s, and then the 3 represents 16 to the second power, which is 256. So we have 3 times 256 plus 10 times 16 plus 12. So 3AC in hex is equivalent to 940 in base 10. And once again, if we want to convert a decimal number to hex by hand, then we need to do repeated division by 16. And again, we write down remainders starting from the right. And when the quotient is less than 16, then the process will stop. Okay, and again, the most significant digit will be the final quotient. Okay, so for example, we need to convert 9,143 in base 10 to hex. Okay, so we divide 9143 by 16, we get 571. We keep the remainder, which is 7. Then we divide 571 by 16 and get 35, with remainder 11. And remember, 11 is going to be represented in hex by B. And then we divide 35 by 16 and we get 2 with remainder 3. So this is the end of the process because the quotient is less than 16, and so our hex representation is going to be 23B7. And again, if we need to convert from binary to hex, then the process is much easier because 16 is just 2 raised to the 4th power. So all we need to do is convert any string of 1s and 0s, binary 1s and 0s, to hex, is just group the bits by 4 and convert to a hex digit. So we have this string of 1s and 0s in binary to convert. First thing we do is group them by 4s from the right, and then look and see what each group of 4 is going to be represented by in hex. So let's see, here we have a 1, and there's a 4, so that's 5, and there's an 8, so that's 13. 13 in hex is going to be represented by D. So there's a D, there's a 9, there's a 4, there's an F, and there's another 4. So we have 4F, 4, 9D.